In my hand here, I'm holding an orange and an apple. Because of my eyes being very powerful and my brain being very powerful, as soon as I can see this, I can tell that this is an apple and this is an orange. Now this has for a long time been something only humans can do. So how can we teach computers to do the same thing? As with any other machine learning problem, the first place we need to start is with the data. For this project, I used this Kaggle dataset. Let's take a look at the data and see what it's like. Well, yeah, those are not very high quality pictures.
Won't they make for a pretty bad model?
Actually, not really. By varying angles, poses, lighting, quality, and all these different things, we can actually replicate real-life supermarket scenarios. This helps our model prevent overfitting. Overfitting is when a model becomes too perfectly tuned to a certain dataset, to the point where it actually starts memorizing rather than actually generalizing and learning. This basically makes our model useless, so we don't want it to happen. The next step is to represent images as data. Images are essentially three-dimensional matrices with one matrix each for red, green, and blue, and each pixel has its own value between 0 and 255. This is what we're going to be feeding into our network. It's neural network time! For this project, I use a convolutional neural network, which is commonly used for image classification. Essentially, what it's trying to do is trying to get the computer to see higher-level features. For more detail, you can always check out my article with the link in the description. The key behind a convolutional neural network is, you guessed it, a convolution. A convolution is essentially passing a kernel over the image in order to detect features. Here's an example of a convolution designed to detect horizontal lines applied to this image of a house. These convolutions act as the eyes of the computer, but the brain is made up of fully connected, or dense, layers, and this is the part that actually does the classification between oranges and apples. For this project, I trained 4 different models, and they all did really well. The best one was the model with 3 convolution layers and 2 dense layers. And that's it for this video. If you want more detail, you can always check out my article on Medium, or check out the code on my GitHub. Links will be posted in the description. Thank you so much for watching.